Hello everyone, my name is Ege and my student number is 250140011. This is my practical skills assessment for the Secure Computer Networks module. Today I am going to present a novel physical to digital attack chain. I will start by walking you through the theoretical architecture and the meter attack mappings using my slides. Then we will jump into the live virtual machines to see the entire attack execution in real time. So let's get started. If we move to the next slide, we can look at the threat landscape. Right now, organizations are heavily focused on securing their cloud environments. To protect data privacy, many are shifting towards unethered local AI models like the Tiny Llama instance I'm targeting today. But this creates a massive security blind spot. Users place a huge amount of implicit trust in these local assistants, sharing passwords, crypto wallet details, and private data. Unlike cloud servers, these local AI logs, like the history.json file, are rarely encrypted at rest. As we can see on the CIA try slide, my attack completely shatters this localized security. I breach confidentiality by exfiltrating the unencrypted AI chat logs. I compromise integrity by poisoning both the Windows host file and the AI model's parameters, and I disrupt availability because the legitimate AI assistant is overridden to serve my attacker infrastructure. Looking at the architecture, the hardware vector is a Raspberry Pi Pico acting as human interface device, and the target is secure VM, Windows VM, running a local AI. My command and control server is a Kali Linux machine hosting a custom Python profiler and an Nginx 2 instance. The attack happens in 4 phases. Phase 1 is the initial access. The Pico injects a PowerShell payload that uses curl to instantly exfiltrate the AI's history.json to my C2 server. Phase 2 is where the attack becomes dynamic. Back on my Kali machine, I wrote a custom Python script called profiler.py using PyTorch. Instead of a generic phishing attack, this script uses natural language processing tensor math to analyze the stolen chat history. It calculates the keyword frequencies to figure out what the user cares about most. For example, Coinbase, Outlook, or the Spotify. This allows me, the attacker, to spin up the exact right phishing page before the user even clicks a link. While the profile runs on my server, Phase 3 executes on the victim's machine. The ducky script modifies the Windows host file, hijacking a generic domain, login.mypage.com, and pointing into my C2 IP. Simultaneously, it uses a malicious model file to mathematically poison the Tiny Llama model. I inject a system prompt so that whenever the user asks about an account, the AI replies with my proxy link. It then deletes the model file to hide its tracks. And finally, in phase 4, the script pulls a rogue root CA certificate from my server via SCP, and it installs directly into the Windows Trusted Root Store. This is crucial because it suppresses browser TLS warnings, allowing my Nginx 2 proxy to intercept the MFA tokens completely invisibly. To summarize this academically, we can look at the meter attack synthesis. We have initial access via hardware additions, execution via PowerShell, and exfiltration over an alternative protocol. We achieve defense evasion by modifying the host file and installing the root CA, and this all terminates in credential access via adversary in the middle session, hijacking. Generic antivirus won't stop this. As you can see on the mitigation slide, defending this requires severing the kill chain. We need strict GPO, allow listing for USB VIDs, and PIDs to block rogue HID payloads. We must enforce PowerShell constrained language modes, and to defeat the Nginx token theft at the very end, organizations must adopt FIDO to hardware security keys, which mathematically bind the session to legitimate TLS channel. Now let's look at the live demonstration. I opened my Windows VM right here and my Kali VM, which is my attacker VM, and Windows VM in this case will be my victim. And on my Kali VM, I already started running my listener Pi, because now I'm telling that I'm waiting and a file, which is in this case it is the history JSON, because it is the best way to determine the target easily, so we can understand what user talks about most of the time with AI. And I already opened my Evolgenix terminal right here. An extra to show the PyTorch I created, PyTorch code, and the other one is for ProfilePy. And on my Kali VM, we need to open the SSH. It's very important because this is that's how we that's how we send the certificate to victim's machine. Otherwise, when the user types our fake phishing email, he will see the connection is not secure screen, which is we don't want to do that. Now we need to open the SSH. Sudo systemctl restart or start SSH. Okay, now let's go back to Windows VM, and here's my PyPico here. Now I'm gonna plug this into my Windows VM, my computer. First, we type PowerShell, and this is very important. We need to start this as an administrator. Now we're sending the history JSON file to our Kali VM and adding the path, which is my fake loginmypage.com, and also we're creating a tiny llama model, so we can say that when the user talks about Outlook or login, tell them visit to this my fake page. And also we are deleting the files, so it is hard to investigate for the forensic team. Now we sent the file, the certificates, and then we typed exit. It shows nothing happened on my Windows victim VM. But if we go back to Kali VM, we can see the file is received, which is stolen history JSON. If we double click this, we can see what user talks about most of the time with AI. Can you help me write a Python script to format some CSV data? And this is the answer, I believe, certainly. What kind of data? And look, if it says login microsoftonline.com, so an Outlook. But imagine there's a lots of data. This is just a dump file. Now we got the stolen history JSON file, and to analyze this, we have to run the ProfilePy. Profile.py. So if we look very closely, high confidence organization identified Outlook. So we can understand that user talks about most of the time about Outlook. And in the, to time's sake, I already created the Outlook fake website. But let's say the user talks Spotify or the Twitter or any other website. We're gonna have some time to create a fake website, which is very important in these situations. And now on my Windows VM, let's open the CMD and run our local AI, which is ollama run tiny llama. And let's type hello, what was my Outlook address, can you send it to me? Now the AI, we can see the AI is poisoned because this is not the official website that Microsoft owns it. But in this case, user doesn't know which one is the official one and which one is the fake one. He just trusts what local AI says. And let's go to Microsoft Ege. Now I just copied the fake website and paste it here. Now it seems all of the website seems the real. Now user types its real email. Now I created a fake email, which is admin@m365x, like that. This is the fake Microsoft email. And if you click next, enter password. Let's type something here, something random. It's not important user to type the real password. Either way, the user will get an error message. Click enter, and we can see your account or password is incorrect. And if we go back to Kali VM, we can see detected. We get token and the email address, which is admin and at m365, and our password is look here, 1237. This is just username and password, but if we type sessions, we can see the previous sessions, what we captured before. And the last one is this. It's something like history, Evolgenix. And if we type session and the ID number is 14, sessions 14, now we get the token here as well. So demonstration I learned we should not be trust all the local AIs or the AI models, because AI could be poisoned and we can lose all the credentials, all the passwords, informations, and which is very crucial in this industry. And we always have to check the official websites.